Chapter 2, Lesson 3, Solving Multi-Step Equations. So now we're going to look at equations that have more than one step to them. So the first thing that we are going to do is we are going to get rid of any parentheses. And we remember from last chapter, how do we do that? We distribute if we need to. Sometimes we don't need to. The second thing that we are going to do is to combine any like terms if we have them. So either the term with the variable or any constants. And then we are going to undo any addition or subtraction. And then we are going to undo any multiplication or division. Look at some examples. So we have 12 equals negative 7y plus 9. So there's no parentheses. There's no like terms because I have to then remember I'm looking at each side of the equal sign individually. So over here there's only a 12, and over here there's a negative 7y and a minus 9. So none of those are like terms. So I'm going to undo the addition or subtraction. So here's my variable, and I am multiplying it by negative 7 and subtracting 9. So I'm going to get rid of the subtracting 9 by adding 9. And then that cancels out here. Remember, my equal sign is like a wall. I must put plus 9 on both sides. So over here I have 12 plus 9 is 21 equals negative 7y. I get rid of this times 7y, negative 7y, by dividing by negative 7y, and I get negative 3 equals y. Okay, let's move across. So we have c plus 1 over negative 3 equals negative 21. Now this one's a little bit tricky because our order of operations would tell us to do the c plus 1 first and then divide by the negative 3. So the first thing I'm going to get rid of is the divided by negative 3. So I'm going to do times negative 3, which gets rid of that. So I have c plus 1 equals 63, and then subtract 1, c equals 62. All right, down here at the bottom, I'm going to get rid of the parentheses. So 3a plus 6 plus 2a equals 1. Then I'm going to combine like terms. So 5a plus 6 equals 1. Get rid of the addition or subtraction. So 5a equals negative 5. Divide by 5. And a equals negative 1. Some things that we're going to look at is when we talk about things like consecutive integers. We're talking about integers that come in counting order or right in a row. So we're going to look at three different types. The first type we're going to look at are consecutive integers. And we're going to describe them as integers that come in counting order. Okay? And when we talk about symbols, how do I write that using variables? Well, if my first integer is n, then my next integer is the next one that comes in order is n plus 1. And the next one that would come in order is n plus 2. And the next one, n plus 3. The next one, n plus 4. And so on. Okay? When I look at examples of consecutive integers, I'm looking at things like negative 1, 0, 1, 2, 3, 4, and so on. All right, then we're going to talk about consecutive even integers. And so consecutive even integers are even integers followed by the next even integer. And when we talk about symbols with that, we put n. Now the next even integer, so let's say that n is 10. The next even integer would be 12. So it's not n plus 1, it's n plus 2. And the next one would be 14, so then n plus 4, and then n plus 6, and then n plus 8, and so on. Okay, examples, let's just use that example. 10, 12, 14, 16, 18, and so on are consecutive even integers. And the last one we're going to look at are consecutive odd integers. And they're very similar to even integers, so obviously they're not even, they are odd integers followed by the next odd integer. Okay, so when we do symbols, this one's a little bit tricky because if we start with n, so let's say we start with an odd number with 15. Well, our next odd number is 17. So how would we represent that? Not n plus 1, it's also n plus 2. And the next one would be 19. So remember, 15 is like n, so then we do n plus 4, n plus 6, n plus 8, and so on. Just like we have 19, 21, 23, and so on. Use this for, let's say that we have a problem that says find 3 consecutive odd integers with a sum of 51. So my first odd integer is going to be n, the next one is going to be n plus 2, and the next one's going to be n plus 4. So 3 consecutive odd integers with a sum, so I'm going to add them together, n plus 2 plus n plus 4, and that needs to equal negative 51. So now I'm going to follow my steps. No parentheses, combine like terms, n, and n. 3n, 2 and 4 plus 6 equals negative 51. Get rid of that addition. So 3n equals negative 57. Divide by 3, and n equals negative 29. Now, what that tells me is that my first odd integer, n, is negative 29. My next one is n plus 2, so my next one is negative 27. And my next one is n plus 4, so negative 25 are my 3 odd integers.